Okay, the four questions that we're going to do here are modulus questions. So to solve modulus questions, we will need to first draw the graph without the modulus signs, and then we reflect it about the x-axis, thereby creating the modulus question, thereby solving the modulus question. For our first question, which is y equals x minus 3 with a modulus sign. So to solve it, we would solve it like how we would do it without the modulus sign. So important things to take note would be the intercepts. So for all four questions, to find the y-intercept, we will let x equals 0 here. And we'll solve it like how we would solve it without the modulus sign first. So when we let x equals 0, y equals negative 3. And to find the x-intercept, we will let y equals 0. So when y equals 0, x will be 3. And the questions ask us to draw the graph between 4 and 0 inclusive. So we would draw it like how we would draw it without the modulus sign first. But once we reach the x-axis, we will continue with a dotted line all the way to 0. And after that, we will reflect it about the x-axis, thereby getting y equals x minus 3 with a modulus. For question B, again we use the same method throughout. So we are asked to solve y equals modulus x plus 2 from 3 to negative 3 inclusive. So again we find the y and x intercept, which is 2 and negative 2, and then we would draw it from 3 all the way down to negative 2, and beyond that, since it's in the negative y-axis range, we will reflect it up such that at x equals negative 3, y would equals to 1, because without the modulus, it will be negative 1. So once we reflect it up, it would be positive 1. For question C, again we would first find the y and x intercept, which would be negative 1 without a modulus sign, and x will be equals to half. But notice this question, it is inclusive of positive 3, the range is inclusive of positive 3, however it's excluding negative 1. So when we draw our graph, at a x equals negative 1 range, we draw it with an open circle, and when x equals positive 3, we do it with a full circle. So we will draw it like how we would draw it without the graph without the modulus sign first. But once we reach the negative region along the y-axis, we would go with a dotted line, and then we reflect it along about the x-axis. So we flip it up again. We know that the y-intercept will be positive 1 now instead of negative 1 when it was without the modulus sign. And once we reflect it up, we'll end all the way to in the range of x equals negative 1. For part D, y equals 3x minus 5 with a modulus sign again. We'll find our x and y axis as though we'll find it without the modulus sign first. And for all y-axis that is on the negative region, we will reflect it about the x-axis and put it over to the positive range of the y-axis. So we find that the y-intercept without a modulus sign of the question would be negative 5, and the x-intercept would be 1 and 2/3. Our range here would be x from excluding 0 to 3 inclusive. So we would draw the graph like how we would draw, as though it does not have the modulus sign. But once we reach the x-intercept, we will continue with a dotted line. After that, we will just reflect the dotted line about the x-axis, and then we will draw a solid line for that. Again, notice when x equals 0 is excluding 0. So we will draw it with an open circle, but when x is inclusive of 3, we draw it with a full circle.